Hey students, by the end of this video you will be able to know what a titration curve and be able to calculate some of the pHs at some of the, or all of the pHs at some of the important points in the titration curve. So, like we've discussed previously, a titration is a way of adding a very precise amount of strong acid or strong base to the opposite weak. So if you have a strong acid, you typically are going to add that very slowly and precisely to a solution of a weak base. Strong acid goes into a weak base, or there's a strong base goes into a weak acid. Okay, and so that's what we have here. If we look at this guy here, okay, this is what happens before the titration. This comes out here and falls into the solution, and then we measure how much we add until we get to the very end of the titration. Typically it's marked by a color change of an indicator, or sometimes it's we'll use a pH meter. Okay, this idea, there are kind of like 2 or 3 points that are kind of important on a titration curve, and one of them, the most important one, is called the equivalence point. Okay, the equivalence point is when the quantity of a strong component, so like strong acid, is equal to the amount of weak component stoichiometrically. Okay, so we're going to obviously go over some samples to talk about this. Okay, now I'm gonna move over pretty quickly what happens when you titrate a strong acid with a strong base. I'll move this so that you can see it a little bit better. Okay, so because when we do a strong acid and a strong base, this becomes really just a stoichiometry problem. Okay, in order to find the pH of this, okay, when you mix a strong acid and a strong base, you do the stoichiometry part of it, and then once you do that, then you can just find out what there is left. If it's hydroxide ion, you do the pOH. If it's hydronium ion, you do the pH. Now, the key here is that the equivalence point, when you have a strong acid and a strong base, the equivalence point is at 7. Okay, the pH when you titrate a strong acid and a strong base is at 7. Okay, now we're going to move forward here. Okay, let's move through this. Okay, so now let's see, we're going to titrate a weak acid with a strong base. Now look at what happens at the equivalence point, the point where the amount of weak acid equals the amount of strong base. At the equivalence point, the pH is going to be above 7. That is important because if we look at our process for determining the pH in a titration, remember we have the strong base plus the acid, in this case it's HA, is going to react one way, in only one direction, react to form H2O plus A minus. So now we actually get to see what it means to be at the equivalence point. To be at the equivalence point, whatever the concentration of hydroxide is, and I'll change color just so I can do this. For example, if we have a concentration of hydroxide that's 0.2 molar, that means the concentration of acid is 0.2 molar. Now, when we do that, that means that in our stoichiometry step here, okay, we have to determine which is our limiting reactant, and they're both our limiting reactant, so this is 0, 0. But now what do we have here at the end? Okay, at the end here, this is 0.2. Well, what is this compound? This is the conjugate base. And what's the pH, would you guess, of a conjugate base? It's above 7. So this is the chemistry behind a titration. Okay, so this is the chemistry behind the equivalence point. So that's what you get. That's what we see here. And then whenever we do these sorts of titrations, we typically use phenolphthalein in the lab because it's what we call its endpoint is right around the pH of the equivalence point, the endpoint of the indicator. Okay, so let's move beyond this now. Okay, move this out of the way. Okay, it says oh, I'm sorry. Let's do this here. One of the other things to note in a pH, in a titration curve, okay, let's talk about the shape of the titration curve here, is that notice you have this, it starts out at whatever the pH of the weak component is, and then it moves in here. Okay, well, what's happening in here? Why isn't the pH changing? Well, the pH isn't changing because here you have a mixture of the weak acid and the conjugate of that. And what do we know the weak acid and the conjugate of that is? That is called a buffer. So this part is called the buffer region, and so that's why we kind of built the unit the way that we did, is because we needed to know about buffers, and then we talk about titrations, the shape of the curve, the equilibrium, the equivalence point. Okay, and so within the buffer region, there's also something called the halfway point. Okay, I'll abbreviate it here. Okay, the halfway point, and the halfway point is where the pH equals the pKa, or the pKa equals the pH. And that's kind of an important point too. Okay, so if you get to the equivalence point at 50 milliliters of sodium hydroxide, that means the halfway point is at 25 milliliters of sodium hydroxide. And at that point, since the Ka doesn't change, so that means the pKa isn't going to change, then we can calculate the pH. So it gives us all sorts of points that we can calculate. Okay, so just real quick as we go over this one more time, we have the equivalence point, which is the point where you have the amount of weak component equals the amount of strong component stoichiometrically, so number of moles. Okay, you have the halfway point where the pKa equals the pH, and you have this buffer zone because you start off with maybe a weak acid, but it turns into a buffer almost right away, and the pH doesn't change because you are having a buffer. It's not that it doesn't change, it just doesn't change dramatically. So there's all sorts of neat things that happen in here mathematically. Okay, so let's take a look at a titration. And so the example that we're going to do is number 45 in Brown, LeMay, Burston. Okay, it's this one right here. So you can see the problem. Now look, we're going to do 1, 2, 3, 4, 5, 6 different parts that all have to do with one titration. And at the end, I'm going to show you some shortcuts maybe that will help you figure this out. Okay, so this may be a long problem. Actually, what I'm going to do is I'm going to do this on a separate video. That way you have a chance to just watch just this problem going through. So I wrote it down here, and we will go from there. So we'll see you in the next video.